All right, welcome everyone to the January 2026 Water Conditions Monitoring Committee meeting. My name is Emily Adrid, and I'm with the Colorado Water Conservation Board. Today we have presentations from the Colorado Climate Center, NRCS, and then we have a quick presentation from our colleagues at Linker. And then we'll get into our updates from water providers and water managers today. So I think we should get started since we have a busy agenda. So Allie, go ahead and take it away.
Awesome. Let me just get my screen already here. Can everyone see these slides okay?
Yep.
Perfect. Yeah, so if I haven't met any of you, it's been a while since I've done this. My name is Ali Mazurek. I am a climatologist with the Colorado Climate Center. So we're just going to run through some updates of what we have seen over the last few months. But first, I'm going to start off with we got our final numbers for 2025, the calendar year 2025. So I just wanted to recap kind of what that looked like. Very quickly. Kind of finalizing these numbers, statewide, we had the fourth warmest year on record for Colorado. This was behind only 1934, 2012, and 2017. Across a lot of the western slope, where you see these darker colors, that was the record warmest. And then there's some other pockets of that elsewhere, and then kind of top 10 warmest for much of the state. And then taking a look at precipitation. Looking at 2025 as a whole again and statewide, it was the 31st driest year on record statewide. Top 10 driest for some locations across Western Colorado and Northwestern Colorado, top 20 wettest for portions of the Northeastern Plains. So, once again, we kind of had this pretty sharp west-east divide in precipitation that was a pretty big theme of 2025. And of course, with climate change, we've seen kind of this rapid increase in warming temperatures since 2000 or so. And notably, with the fourth hottest year on record occurring in 2025, we now have 8 of the 10 warmest years on record. 8 of those 10 have occurred since 2012. So quite remarkable warmth that we've seen over the last decade and a half in Colorado. So now looking forward, kind of at the last few months, I really think that this picture here on the right sort of sums up the current situation in Colorado pretty well. This was taken by my colleague Henry Regis at the Big Thompson Headwaters on December 23rd. A nearly ice-free river at the headwaters, basically no snow on the banks, very little across the mountains. So I think picture's worth 1,000 words there. So, taking a look at the last 3 months, so kind of at the start of water year 2026, October through December, this 3 month period was the record warmest October through December on record. Those records, again, date back to 1895, so 131 years of data. These dark red colors that you see on the map here are all of the areas in Colorado that experienced record warmth over that 3 month period, and then top 5 to 10 warmth kind of in a few isolated pockets throughout Colorado, including the San Juans. And then kind of breaking this down by month, December 1st, record warmest December. I'll talk a little bit more about that in a bit. And then October and November were also pretty remarkably warm as well. And then looking at precipitation, um, we have kind of been a bit drier than normal over the last 3 months, not remarkably so. Part of that can be attributed to, I'm sure a lot of you remember the wet October that we had kind of in southwestern Colorado. We had those couple of remnant of tropical systems that brought moisture to Colorado, led to flooding in the Pagosa Springs areas and other areas of southwestern Colorado. So that's kind of tampering some of this drier signal that we've seen. Kind of this drying has sort of ramped up a bit in November and December. Um, but again, kind of not remarkably dry if you're taking a look at it on a statewide level. And we'll kind of break this down a little bit further. But taking a look at our quadrant chart here, so again, this is for the 3-month period, October through December. This is comparing 2025 to past October through Decembers. On the x-axis here, you'll see precipitation, accumulated precipitation statewide, and then average temperature statewide on the y-axis. So 2025 really stands out, that October through December period of being record warm. Also on a statewide level, drier than normal as well, but not to the extent of that record warmth. And then kind of breaking this down a bit by a couple of our drainage divisions. So this is the Platte Drainage Division, number 4 on the plot over here on the left. And you can see kind of that particular area has sort of outpaced the drying on a statewide level. So we've seen kind of drier conditions in this particular area than compared to what we're looking at statewide. If you're wanting to look at a couple analogs, kind of similar conditions to what we saw in 1999 and 2021 in terms of dryness. And then on the contrary, taking a look at the Rio Grande Drainage Division, which is number 5 on this map over here, that area is actually still running wetter than normal, again, thanks to those October rainstorms that brought record-setting precipitation to that area. But the story has changed a lot kind of since we had that rainfall in October, and we'll discuss that a little bit further here. This picture here on the right was actually a picture that I took. We had a small grass fire behind the CSU Foothills campus back on December 18th. This was actually due to a down power line from a windstorm the day before. So, we'll talk a little bit more about that wind and kind of fire danger that we saw during December as well. So I kind of alluded to this earlier. We got our December temperature rankings. First warmest, record warmest December on record statewide for Colorado. Breaking it down spatially, these darkest areas are areas that experienced their warmest December on record. And then kind of top 5 to 10 warmest elsewhere, probably top 2 to 3 warmest for most of these locations that are in kind of this lighter red color. As my boss, Russ Schumacher, our state climatologist, put, December really was disturbingly warm. We saw temperature anomalies as large as 10 degrees or warmer in some locations. That's, again, those darkest reds that you see here. Those are locations that saw average temperatures in excess of 10 degrees or more for December. But again, pretty remarkable warmth statewide. And then taking a quick look at precipitation, December was our 34th driest December on record out of 131 years of data. Areas that we saw that were particularly dry relative to their long-term records, northeastern Colorado, some places in northeast Colorado saw almost no precipitation during December, which is not necessarily unheard of. December is one of the driest months in northeastern Colorado, typically. So, drier than normal conditions in December isn't necessarily a make or break for water concerns, given that relatively little of the annual precipitation falls there during December. And then meanwhile, looking further to the west, in southwestern Colorado and parts of the West Slope, we also saw abnormally dry conditions there. And actually, statewide, pretty normal elsewhere, though kind of leaning more on that dry side. And then this is the January precipitation that we have seen so far. This is as of 6 a.m. yesterday. I don't think any additional precipitation has fallen since then, so this should be pretty up to date. As you can see in this map here, the shading is our data set from PRISM, which is a pretty reliable precipitation data set in terms of its ability to handle elevation in Colorado. And then these points that you see here are data from CoCoRaHS, and then our overlaid contours are the current US Drought Monitor, which we'll talk again more about later. So you can see from this image here that there has been some mountain snow. Again, northeastern Colorado has continued to stay mostly dry throughout the start of January. But then if we take a look at the percent of normal precipitation that we've seen in January so far, really most of the state has been drier than normal. Again, an area that stands out is northeastern Colorado, that kind of those long-term precipitation deficits are starting to stack up there. We've seen drought conditions kind of expand in that particular area. And then kind of the area that stands out here, sort of from the rest of the state, is southeastern Colorado, which got kind of a nice shot of snowfall earlier this month. Some locations saw upwards of about 10 inches, which is quite a lot for this particular time of year. So I sort of mentioned this earlier for northeastern Colorado that January is not a particularly important precipitation month when we're looking at an annual time scale. We tend to get more of our precipitation on the eastern plains later in May and June when we get thunderstorm activity. But it is an important source of precipitation for some of our mountain locations. One area in particular is the Park Range, which is west of Steamboat, or east of Steamboat, rather. That area, January is one of the biggest like one of the months that they see their most precipitation on an annual basis compared to other months out of the year. And then the same is true for parts of the San Juans as well. So seeing precipitation deficits there in January is a bit concerning for their water supply. So just giving a few more details on this record-breaking warmth that we saw in December, we saw across the whole month over 1,000 daily maximum and minimum temperature records broken throughout December. This is just one of the very warm days that we had in December. Something that makes this plot particularly remarkable, we see plots that we see maps that have record-setting temperatures across lots of places in Colorado, but seeing record-setting temperatures in all four corners of the state on the same day kind of really speaks to the widespread warmth that we were having on a state level. And again, it's not super unusual to get temperatures in the 60s across parts of the eastern plains of Colorado. That's not unheard of, but the frequency that we saw that in December is pretty remarkable. So these are a few of our long-term weather stations that have long-term records. So I took a look at the number of 60-degree days that we saw in December 2025, and every one of these stations that I have listed here broke the record for the number of 60-degree days in December 2025. And you can see the previous record here on the right. A lot of these were previously set back in 1980, which was also a very, very warm December for Colorado. But for many locations, not quite as warm as 2025 was. And then these underlined locations I have here were places that saw more 60-degree days than not 60-degree days in December. So more days that hit 60 degrees or higher than days that did not, which is, again, pretty remarkable. I think that this is another graph that kind of speaks to the magnitude of the warmth that we've seen so far. I mentioned that January has continued to be very, very warm across the state. So far, looking at the Fort Collins weather station, which has records back to the late 1800s, we have seen 26 60-degree days or warmer in Fort Collins from December through January so far. I think this will be it. I don't expect to see any more 60-degree days in January. That could change, but I think that that will be our final total. But seeing 2025 through 2026 here stands out a lot amongst the previous years. Previous record 14 in 1981. So nearly double that. The same is also true in Denver as well as Colorado Springs. This image here is showing it for Denver. Again, 1980 really stands out, but once again, not quite as warm as December 2025 through January 2026 has been. And then another big story for December was the downslope windstorms that we had. We had several days with very strong downslope winds that affected the Front Range and adjacent plains, as well as parts of the Eastern Plains. I'll talk more about that on the next slide or so. we had several gusts that exceeded 100 miles per hour in parts of the elevated terrain. Um, I'm sure some of you were perhaps affected by some of the public safety power shutoffs by Excel. We had a few days of that. So again, kind of that was another big story of December. And so with that wind came fire danger. On December 19th, the NOAA Storm Prediction Center actually issued an extremely critical risk for fire weather. Again, that was on December 19th. These risks in northeastern Colorado in the Boulder forecast area are pretty rare. We get them on average maybe 1 to 2 times a year. But since these have started being issued, which is about, I think, back to like the maybe early 2010s, we have never seen one of these extremely critical risks in December. I think that the closest that we've gotten to December is March. But again, have never seen kind of this extremely critical risk put out by the Storm Prediction Center. So a good reminder that our fire season kind of across the lower elevations in Colorado can be year-round. And in fact, while I'm sure a lot of the power shutoffs kind of helped mitigate some of that potential fire danger, we did see some fire further east. So on one of the very strong downslope wind days that we had, there was also a very strong front that pushed across eastern Colorado. And that kind of really kicked up the winds out there, and presumably brought down power lines. I don't want to speak to what the exact cause of these fires were, but multiple fires broke out across Yuma County, burning over 14,000 acres before being extinguished the next day. So of course, kind of those dry, windy conditions sort of helping to expand that fire risk and kind of flame those flames. So looking at drought conditions next, again, another photo from my colleague Henry Regis. I feel like this is kind of the classic photo that you would get if you looked up drought on Google. This is from Dixon Reservoir in late December. So this is the current drought monitor. Typically we have WCMC on Tuesdays, but since it was on Thursday, I was able to pull the most recent drought monitor that was released this morning. So this is hot off the press. This is looking at statewide, and then I'll zoom in here, looking at just the west. So this is the drought monitor change map over the last 4 weeks. Across parts of Colorado, Wyoming, New Mexico, we have seen some drought starting to expand over the last month or so, and then improvements elsewhere across portions of the West. Some of those locations have benefited from some atmospheric river activity, but we've stayed, again, pretty dry here in Colorado. And then this is just looking at the 8-week change map in the drought monitor. So that goes back to right around Thanksgiving to now. And again, expanding drought conditions has been the story across Colorado and parts of Wyoming. And then this is just zooming in Colorado. One notable thing that happened in December is that we saw the return of exceptional drought areas to Colorado. That is the most extreme level of drought. That in the current U.S. Drought Monitor, that's covering portions of Eagle, Pitkin, Park, Lake, and Summit counties, kind of in central Colorado. And when we're looking at percentages statewide, we're seeing about 16% of the state currently in severe or D2 level drought or worse as of the current drought monitor. And then again, this is the change map, but now just looking at Colorado, this is compared to, again, right around Thanksgiving. Here's a reference of what that looked like around Thanksgiving, and then the change map that we've seen since then. Drying across a lot of parts of Colorado, including the return of drought to southwestern Colorado that was formerly drought-free thanks to that fall precipitation that they saw. Again, lots of drought degradations across the central mountain areas of Colorado, and then drought expansions on the northeastern plains as well, as those precipitation deficits have started to stack up. And not much in the way of improvements, only a few areas that kind of lucked out on seeing some isolated better precipitation over that 8-week period. And then kind of taking a look at a couple of our drought indicators. So this is soil moisture from the WLDAS product, which takes into account both satellite data as well as land-based modeling data. So on the left here, this is 10 centimeter soil moisture percentiles. And then on the right, that is 1 meter soil moisture percentiles. And obviously, this is just one of our soil moisture products, but something notable to see here is that we've seen those expanding drought conditions in northeastern Colorado, but kind of those deeper soils do seem to be holding on to some of that moisture that they saw kind of in the late or early fall, late summer. So that is perhaps one point of positivity, but it does seem like kind of those shallower soils are starting to dry out. And I think I have a change map that kind of maybe is another way of looking at this. So not huge changes over short time scales over that particular part of the state. But obviously what stands out here is southeastern Colorado, which their soils really kind of moistened up from that precipitation that they got in early January. So positive signs for kind of the Arkansas River Basin and surrounding areas, at least as of right now. And then one more drought product here. This is evaporative demand drought index, which is essentially showing how much demand for evaporation there is. And kind of these darkest red colors sort of correlate with the most extreme drought category. And as you can see for Colorado, evaporative demand across the state has been very, very high. This is for the 3 month period, but the 2 month maps as well as the 1 month map look pretty similar to this. Again, that's been driven by our warm, windy, relatively dry conditions that we've been seeing since at least November across most of the state. And then taking a look at the outlook, moving ahead, what are we going to expect? Will we ever see snow like this again? Maybe, but maybe not anytime soon. So this is looking at the NOAA 7-day precipitation forecast. We do expect snow for this weekend. So that is at least one point of positivity. Not really expecting this to be a drought busting event, especially across northern, kind of our northern mountain areas, not really seeing a huge amount of precipitation with this system. Perhaps a little bit of better news across southern Colorado. But again, this, isn't going to wipe out all of the drought that we have that's been going on across the western part of the state and our mountain areas. And so this is taking that map from the past image and then comparing it to the difference in precipitation that we would expect on average for this time of year over a 7-day period. So again, kind of, even though we're seeing precipitation expected for a decent portion of Colorado, this amount of moisture is still kind of below average for what we would expect this time of year across the northwestern part of the state, above average for the southern and southwestern part of the state, at least some areas of it. So again, perhaps one point of positivity. So could add a boost to our snowpack in parts of the San Juans and Sangre de Cristos, but probably not as much of a meaningful snow for areas north of I-70. And then taking a look at what we are expecting for temperatures. This is the European model ensemble for temperatures out to February 6th here. And so we're actually expecting with this snowfall system this weekend a pretty big cold snap. So up on the top here, I have those predictions from the European model for Grand Junction and then Denver on the bottom. And then these two gray lines here are our average maximum temperature and average minimum temperature at those two locations for this time of year. So below average temperatures, much below average temperatures for some locations look likely this weekend. For many, this is going to be kind of our first big shot of winter that we've seen so far this year. I, for one, am happy about that. I don't love cold weather, but I will take anything at this point. And then kind of after this weekend, we're looking at temperatures to kind of warm back to near or slightly above average as we round out January and look towards February. So just want to mention for folks that live in Eastern Colorado, and I mean, really everywhere is going to be experiencing pretty cold temperatures this weekend, but worst of it will be on the eastern plains of Colorado. Sub-zero wind chills possible Friday night through Monday morning in Colorado. our actual temperatures will probably also be close to or below zero across most of the Eastern Plains. So use your cold weather cautions. Be careful if you have to be outside. And then looking towards our precipitation forecasts, again, this is from the European ensemble. Now I have Steamboat at the top and then Denver at the bottom. After this weekend, our next chances for precipitation do not look to be likely until at least early February, maybe longer. Slightly better chances in our mountain areas. Sometimes just a little bit of lift can give us some orographic snowfall in those locations, but not great news for snow lovers on the Eastern Plains, at least at this juncture. And then this is just another way of looking at that. Again, this is the European ensemble. And so essentially what this is showing is out of our 50 ensemble member forecasts, how many of those are predicting above average, below average, or near normal precipitation. I've kind of been talking about northwestern Colorado, even though that area probably will see some precipitation this weekend. Again, it's not the amount of precipitation that we would expect for this time of year in that area. And then southern Colorado is likely to get a boost of precipitation from this weekend. Looks like slightly above average is likely in that particular area in terms of precipitation, and then near normal across most of the plains. We might get a little precipitation out of this storm this weekend, not a lot, but again, this time of year for the Eastern Plains tends to be relatively dry, hence kind of the near normal precipitation outlook here from the European ensemble. And then looking at the outlook from the NOAA Climate Prediction Center, this is the 8 to 14 day temperature outlook on the left, and then 8 to 14 day precipitation outlook on the right. So that covers the January 29th through February 4th period. A very sharp west to east divide in temperatures across the United States here. Out west, we're looking at above normal temperatures over that period. Again, not great news there. And then for precipitation, looking at below normal precipitation, elevated chances for that, particularly across the western part of the state, near normal across the eastern part of the state. We might get a little precipitation in that time period, but again, not much. And then NOAA released their seasonal outlook covering February, March, and April a few days ago. So again, like the last image, this is seasonal temperature outlook on the left, seasonal precipitation outlook on the right. So looking forward to the rest of winter and the start of spring. Looks like for southwestern Colorado, expecting elevated chances for above normal temperatures in that part of the state, near equal chances of below or above normal for the northeastern part of the state. And then for precipitation, looking at elevated chances for below normal precipitation in southern Colorado, kind of in northern Colorado, we're sort of wedged between these elevated chances for above normal precipitation to the north and below normal precipitation to the south. And our seasonal forecasts right now are particularly challenging because while we still have La Nina conditions in place, there is the expectation that we will be shifting to ENSO neutral conditions over the next few months. If you can look at the February, March, April bar graph here, this gray bar is the probability of seeing neutral conditions during that time period. As you can see, that's almost sitting at 90%. So there's fairly high confidence that we'll be seeing that shift from La Nina to ENSO neutral. And in Colorado, as far as we're aware, there is not really a strong connection between ENSO neutral and Colorado precipitation. So that kind of makes this seasonal forecasting in terms of what we might expect for precipitation even more difficult because we don't really have a strong kind of large-scale trend that would be driving that one way or the other. So definitely uncertainty, but that's what we know so far. And then just kind of pointing out some key takeaways. 2025, fourth warmest year on record. December was our warmest December on record. Temperature anomalies during December were greater than 10 degrees Fahrenheit for parts of Colorado, smashed numerous records in the state. November and December have been fairly dry. January has kind of continued this warm, dry trend. We saw a lot of wind in December, which brought power shutoffs, very strong wind gusts, and even some wildfires east of the Continental Divide. And then kind of looking forward ahead at the outlook, looks like we'll be likely to see precipitation and temperatures that are below normal this weekend, and then looking to dry out as we move further towards the beginning of February. So with that, I will end there. Feel free to visit our website or send me an email if you have any questions. And thanks.
Thanks so much, Allie. Um, Not a lot of awesome news there. It's
Yeah.
those quadrant charts, I feel like that you all at the Colorado Climate Center show those every WCMC meeting, and the ones that you showed this meeting were just pretty remarkable, seeing how far warm and dry the October through December time period was. So
Yeah, shocking to say
kind
the
of
least.
shocking. Yeah, I'd agree. Any questions for Allie? All right. I don't think there are any today. Thanks again, Allie, for your presentation. And I think we can move on to our presentation from Brian at NRCS.
Yeah, thanks. Good morning, Emily. Good morning, everyone. Happy New Year. Can you hear me all right?
Yes.
Perfect. Oh, forgot to share my screen here. Let's try. All right. Can you see the main presenting slide?
Yes.
Okay, great. Yeah, good morning, everyone. Forgive me. I developed a bit of a tickle in my throat this morning, so I will try to not cough in your ear. I'll try to do my best here, so forgive me 1 second. All right. Here we go. So just gonna try and wrap up last water year real quick because there is a connection, of course, between where we're at this year. Conditions aren't very well. Um, at this point, you know, Ali showed that. I'll be highlighting that here in a little bit. And then we're also still on the heels of a 2025 water year that wrapped up um, in on September 30th, right? The new water year starts on October 1st. And looking back into 2025, snowpack wasn't that great. It wasn't as bad as it is now, but we were still looking at a dry winter. I think it was about 80 something percent of normal. And then this summer, then into the fall, we were looking at a water year-to-date precipitation number that was about 87% of median. Sorry, actually should have jumped into the slides here. So yeah, the snowpack from 2025 is indicated by the black line here. Where we would like to be in terms of peak is here on the green X. And in 2025, snowpack just really didn't measure up and melted out pretty early, as you can see. This is the green line here is where you'd like to see melt out, but we melted out pretty early on in the water year. Looking at precipitation water year to date, that's indicated by the blue line here. 87% of median is where we ended, which was just a little bit above the 10th percentile. So across the entire state, so still quite dry leading into the beginning of this winter, leading into the new water year starting on October 1st. And as you all know, and I'll be pointing out here in a little bit, the San Juans received some pretty good precipitation in October. I'll quantify that a little bit better here later in the presentation. But just did want to highlight that where some of the moisture was across the state, as we look at least the end of water year values west of the divide, precipitation year to date total ending on September 30th, 2025 was below normal, a bit below where it was in the eastern half of the state. The Arkansas, this number is not right here. This was 95% of median. A little bit closer to normal on the east, but still lacking pretty heavily in the west. So that's how the 2025 water year wound up. Let's go ahead and dive right into snowpack, what we're seeing for this year. And with where we're at this year, right now, I decided to dive in a bit more heavily than I typically do, for good reason. So taking a panning out, let's say, let's look across the rest of the country and just see where things are at. Um, Really, if you look at Colorado here, we're not the only ones that are short on snowpack. When you look out west to Washington, Oregon, most of Idaho, California, even Wyoming, and then the Southwest, New Mexico and Arizona, or snowpack is pretty poor at this point. Fortunately for southern and central Montana, western Wyoming, and a portion of Idaho, snowpack is near normal there. But what we're seeing here in Colorado is definitely not out of the norm. I think some of the drivers as to what's causing that varies. For example, in the Northwest, I think you're all aware of some of the early season rain they received, some of the rain on snow events that depleted their snowpack. You will see here in a little bit that their precipitation across the rest of the country is not exactly indicative of what we're seeing here in this graphic. We just haven't seen the precipitation or snow accumulation here in Colorado. So focusing in more on Colorado, um, the percentages all look quite poor. The southern half of the state looks below 50% of normal, and then just a bit above 50% of normal in some of the northern basins, including the Gunnison. But in this case, when we're looking at snowpack that are kind of on the extreme ends of the spectrum, which we are here this year, looking at these percents of normals, I don't think are the best way to do that. So here in a little bit, I'll get into some ranking slides to show you where at least the more extreme basins are in the state, and where the snowpack is for those basins. So just kind of looking at what we do and how we do it, pretty simple here. The black line is this year, and as of yesterday morning, when I created most of the slides for this presentation, uh, snowpack was at 4.8 inches of water content indicated here. And as you can see, it is below the red line, which indicates that snowpack is at the lowest level that we've seen in the period of record. In the case of the state of Colorado, which is what this graphic is looking at, that is a 40-year period of record. Right now, like I was mentioning, we have 4.8 inches of water content on average across all of our snow measuring sites in Colorado. Typically, at this point in the year, we have about 8.5 inches of water content. If you do the math, that winds up being 57% of median. I wanted to draw comparisons to some of the more similar years or the lowest years that we've seen in this 40-year period of record. So we've got 2018, 2013, and 2000, and I'll come back to these analog years here in the presentation. So this is what I was alluding to earlier, kind of ranking all of the years, as you can see here on the x-axis, compared to where we are this year. And here, well, actually, I haven't mentioned it here yet. Well, I did briefly, excuse me. The state of Colorado snowpack right now is the lowest that we've seen in the period of record. So here we are down here. I can't quite remember the value. I think it's, excuse me, it is 4.8. I can't remember what the 2018 and 13 values were. I think they were 5.4, 5.5 inches of snow water equivalent at those points in time, or at this point in time. So right now, the value that we're seeing is actually pretty low, 4.8. You can see there's a little bit of a step down. Snowpack is the lowest in the 40-year period of record, and is, I would say, comparatively low to the previous 2 years. So wanted to show in this particular slide what our prospects are of getting back to normal. Again, for normal peak snowpack, we're aiming for this green X here. And then here we are right now at the end of the black line, just below the minimum value that we've seen in the last 40 years. At this point in the year, we are 51% of the way through the winter. So we're halfway through winter, or the snowpack accumulation season, as I call it. If we do the math, that means that Colorado needs about 145% of normal snow accumulation to get back to normal. So from here to here, we need 145% of normal accumulation. If you look at the spread of what's happened in the past, you can see that we are very close to the maximum that's ever happened before. So, or excuse me, I should say we're close to needing the maximum amount of snow accumulation that we've ever seen in the last 40 years in order to get back to normal. Very long-winded way of saying there's a very, very small chance that we could get back to normal at this point. If we follow the normal trace, this green dotted line here from where we're at right now, that would put us at about 74% of median snowpack. So we're right now looking at a below normal trend of snow accumulation. If things improve and we get back on track to a normal accumulation schema, then we could expect that we would be back to 74% of median. To hopefully get back to normal, we would need to see a significantly more or a significantly greater change in the weather patterns. Okay, so as I mentioned, there is kind of still a chance that we could get back to normal snowpack, but it is a pretty small chance. And I looked through the analog years, and there were 3 years in which we accumulated as much snow as we would need to get back to normal. And those years were 1993, 95, and 2019. The interesting, what is interesting about these 3 years is they were all near or above normal at this point before they really took off and wound up seeing a significantly increased amount of precipitation and snowpack accumulation. So again, this kind of, in my opinion, fortifies the fact that it's going to be quite difficult to get back to normal. I did notice that while the year 2000 didn't accumulate as much snow from this point to the peak to capture as much as we would need, it was notable that it was one of the lowest years that we had, and we did see a turnaround. That turnaround did start a few days ago, respectively, back in that year, but it was notable that we did receive a significant amount of snow and we did improve our snowpack. Again, I would say the likelihood is quite low, at least based on the analogs. So looking at where snowpack is right now, at least at some of our individual sites, just wanted to show the kind of extreme conditions that we're seeing at our snowtells. The red dots are indicating the lowest snowpack that we've seen in the period of record, and the orange dots indicate the second lowest snowpack that we're seeing in the period of record for these individual sites. And the period of records for these sites do vary, but I think the minimum was set at 20 years. So it is still relatively consistent, or I should say statistically significant to a degree. So nonetheless, a lot of sites that are indicating lowest or second lowest snowpack in the period of record. I tried to take a quick look at this graphic. This is one that is available to the public. This kind of gives an indication of where the snowpack lies. If there happens to be a trend, say, upper elevation sites, the higher elevation sites, which are indicated here on the y-axis, happen to have, say, a above normal or just a higher percentage of snowpack. The percentage of snowpack is indicated on the x-axis here. So higher snowpack here to the right, lower snowpack as a percent of normal over on the left, and each site has its own elevation that it sits at. I've heard that a number of states around the country actually do have snowpack that is a little bit more persuaded towards the higher elevation or whatever it happens to be. In this case, I'm not seeing any real trend here in the state of Colorado, in the entire state of Colorado. And then I, for example, pulled out the South Platte here. I think there is a very slight trend, if my eye is not tricking me or the graph is not tricking me. It seems that maybe there is snowpack is lower as a percent of median at the higher elevations than it is, say, at the lower elevations, at least here in the South Platte. I noticed there was one other basin where it seemed the same kind of slight trend, but I wouldn't consider this very significant in what we're seeing. I will start monitoring these graphics going forward and including them in the presentation if there is something of value. But being as other states around the country were mentioning there was a trend, I thought I'd bring it up and indicate it, but where I'm not really seeing one here. So I thought I'd take a dive into some of the subbasins within the state. Snowpack here in the Colorado headwaters is 55% of median, and it too is the lowest in the 41-year period of record here. Similar years or other very low years were 2013, 2012, and 2020. Interestingly, 2020 and 2013 did see a bit of an improvement in terms of snowpack accumulation rates and storm systems. Hopefully, we can follow that trend, and hopefully we'll wind up seeing snow accumulations and weather systems come in like 2013 and 2020, but I don't think we quite see those indicators out there right now. And then here again, this ranking graph for the Colorado headwaters alone, you can see 2026 is quite low compared to 2012 and 2013. These charts are not available to the public. They're still kind of experimental. As you can see, there's some corrections that are needed. You can see the values in here. We need to just make sure these values get added to some of these other graphics. But I do think these charts are extremely useful on the extreme ends, whether you're out here or out here, to help put into perspective exactly where the snowpack sits with respect to some of those other years. Percent of normal, percent of median doesn't really help convey that as well as ranking does. And then moving down to the Rio Grande headwaters, where coincidentally by ranking, snowpack is the best in the state at 49% of median. You can see that it is not record low in the upper Rio Grande. However, it is in the lower 10th percentile. It's in the 8th percentile, actually. And moving over here, as I mentioned by rank, the Rio Grande is the basin in the state that has the best snowpack at the 4th lowest. All of the other basins are pretty much 3rd worst, other than the Colorado headwaters and the Arkansas. All the other basins are the 3rd worst in the state. So just trying to show the two extremes, for lack of a better term, of what we're seeing for snowpack. Okay, moving on into precipitation again, zooming back out across the entirety of the country. Like I mentioned, precipitation has been much better since the beginning of the water year across much of the country. We really wind up in Colorado, we wound up seeing some of the worst precipitation that the country has seen. And hopefully we can wind up making up for that. Zooming into Colorado again, here looking at the San Juan, you can see that there is better precipitation here than in the rest of the state. But as I mentioned, and as I'll highlight here in a second, that is largely propped up by those October storms. So highlighting that, if we look at precipitation from October 18th beyond that large storm cycle in the Southwest, you can see that precipitation is quite low across the entirety of the state. It's been quite dry pretty much everywhere. A little bit better in the north, but not much better. This is the state of Colorado time series graph for precipitation. Again, you can see the storm from the October timeframe mostly impacting the Southwest. Without that, if we were to shift this down, you would see precipitation would be pretty low in terms of the ranking in the history. Right now, precipitation is at 83% of median. Month to date precipitation, looking at what has fallen since January 1 through yesterday morning, things have remained pretty dry. And really nothing to write home about other than the fact that things are so dry. So as I wanted to help point out how impactful the October storms were in the San Juan. You remember what the graph was for the state of Colorado. The increase was not as high here in that storm system, but looking here particularly at the San Miguel, Dolores, Animas, San Juan, there was a 6-inch jump on average at our SNOTEL sites. Without that storm, if you kind of just brought this down, we'd be down in kind of the 10th percentile. So pretty dry. That storm had big implications on all of the data that we're looking at, both in the San Juans and across the entire state of Colorado, even though there was not much actual precipitation anywhere other than much of the San Juans. Looking at the South Platte Basin, just because it is pretty dry, and looking at the other end of the state, as opposed to the San Juans, you could see that there was barely any accumulation from that October storm set. And so that's why this would be a better indicator of where kind of Colorado is on the long term in terms of precipitation for uh, for the state of Colorado, excuse me. Okay, and then just trying to get an idea of where precipitation could be based on the probabilistic outcomes that have happened in the past. You could see that if we follow the normal trend line, this green dotted line right here, this is where we would be if we did resume or get back to near normal precipitation accumulation for the rest of the year. We'd still be below that 30th percentile. Um, excuse me, yeah, we'd be below the 30th percentile. Hopefully we wind up seeing better precipitation or at least normal and get there. But if we continue on this current track, we'll probably be down below the 10th percentile. And right now, precipitation is in the 15th percentile for the entire state of Colorado. All right, rounding up the last two slides here, reservoirs summed up across the state, reservoirs are at 85% of median. There's some variability across the state and in the various basins of where reservoirs are. 128% of median in the Upper Rio Grande, near normal, just below normal, but still above 90 in the Arc and South Platte. And then west of the Divide, we're looking between 80 and 90% of median for reservoir storage, where it was as of January 1st. And then finally, usually I actually show observed stream flows just to get an idea of where base flows are at. It's a little bit too early in the season right now to show those. Moreover, the way the hydrograph works, the numbers are so small that they don't show it very well on the graphs. So I've removed the current stream flow values and where things are at, but I have included the stream flow forecast values that were projected on January 1st, or I should say using January 1st data. They came out on the fourth or fifth working day as when we typically publish them. The same can be said for February. We hope those stream flow forecasts will be ready by the fourth or fifth working day of the month. You can get them from our website. We will publish them at the Water Supply Outlook Report, usually published on the fifth or sixth working day, so you can find those at a various number of locations. But where were the stream flow forecasts as of the beginning of January? They were relatively low. Of course, you probably are all aware the stream flow forecasts take into account precipitation, snowpack, and current stream flows, and in some cases, some additional factors. So based on where snowpack and precipitation was at the beginning of February, most stream flow forecasts were between about 60 and 85% of median. But the most important thing to keep in mind here is those January forecasts are reliant heavily and based heavily on near normal precipitation going forward. So if we continue to get below normal precipitation, as you look at our stream flow forecast, don't just look at the 50% or the most probabilistic outcome. Look at some of those lower forecasts to anticipate where we could be should we not receive near normal precip if we receive below normal precip. So I'm not going to dive into these too deep right now, again, because it is so early. I will say, though, that because January precipitation has been below normal, I would assume, let me add one piece to that, not only because stream precipitation has been below normal through January, but we're also not looking at a high probability of above normal precipitation through the remainder of January. It looks like things are going to continue to be below normal. I would guess that a lot of these stream flow forecasts come February 1 will go down. So we'll have to see where things land. So in summary, snowpack across Colorado is 57% of median and is no better than the fourth worst snowpack that we've seen in the 40 plus year period of record. The Colorado headwaters and the entire state of Colorado is record low snowpack at this point. In order to get back to normal, we need 145% of normal snowpack accumulation. So it's not very likely that we will get back to normal. And it is very likely that we'll wind up seeing below normal runoff projections this year. Statewide precipitation is below normal at 83% of median. Reservoirs are in generally good standing at 85% of median, and stream flow forecast were below normal as of January 1 and will probably decline come February 1. I think that's all that I got.
All right. Thank you, Brian. Uh, Gosh, okay, below record low snowpack this year. Wow. Okay.
Yep, so far.
Yeah, so far. Well, hopefully, maybe you'll have better news for us next month. Thanks again for the presentation. Um,
Yeah, thank you.
any questions? Looks like we do have a question in the chat. Um, from Adriana, are there any drawbacks to getting 145% snow accumulation during the rest of the accumulation period?
I would say yes. When we're talking about accumulating that much snow over a shorter period of time, it can create problems for um, plowing operations, avalanche concerns. I think 2019 is where my brain goes back to. I kind of think back to some of the avalanche cycles that we saw then, some of the difficulties in measuring snow. It can be a bit of a tax on not only snow measurement operations, but also just general operations. We're not used to seeing so much snow so quickly in a shorter time frame. But on the other hand, it is something that would be nice to have from a water standpoint, looking through the remainder of the year and into the water supply season in spring and summer.
Awesome. Thanks, Brian. Any other questions for Brian? All right. Well, if a question pops up in your mind, just feel free to put it in the chat. Thanks again, Brian.
Yeah, thank you.
Yeah. All right. I think we're gonna switch gears a little bit and we're gonna have Nayang from Linker give us a short presentation on some of the work that they're doing and how you all can kind of participate in some of their data collection.
Hi, everyone. Can you guys see my screen? Yes.
Yes.
Okay, cool. Well, good morning. We're going to change it up just a little bit, and thanks, Emily, for giving us some time to share about mountain rain or snow. We're currently a NASA-funded project focusing on improving precipitation phase estimates in mountain environments. My name is Nayang Her, and I'm a water resources engineer with Linker here in Boulder. And I'm actually joined here with Keith Jennings, Director of Research at the University of Vermont Water Resources Institute, and Ann Hegley, Research Professor at the Desert Research Institute, representing our larger group of mountain rain or snow. We're going to really quickly, briefly cover the why and what of this project and how you all can get involved and hopefully how we can help you and support you in your operations. So with that, Mountain Rain or Snow's goal is to improve estimates of winter precip by crowdsourcing ground-based observations. And we do this because estimating rain versus snow is difficult in complex terrain, like our mountains, and people are often much better at sharing of what's actually falling from the sky. So having a better understanding of precip phase is critical, like we just talked about, and like you all probably know. But our observations have helped validate data products that feed forecasts and support public safety and awareness. And Keith and Ann will expand more on these use cases in a little bit. But essentially, we collect observations through a web-based app, and this is what that interface looks like, where observers can submit an observation of rain, mix, or snow, and that's it. And as you can see on this map, our largest observer base are here in the Rockies, the Sierras, and in the Northeast. And actually, by the end of this past water year, we've had over 115,000 observations. And actually, as of yesterday, we're at about 128,000 observations, which I am firmly believing that it's our Eastern observer base that's holding it down for us. But when we look here in Colorado, this figure here shows the distribution of phase observations across this water year, or across the water year in general. And as you can see, we have more reports in the winter, and that's actually because that's when our project is the most active. And during these months, we actually send out notifications about upcoming storms in the area. And just quickly over stats in Colorado, we have about 1,226 unique observers in Colorado who've submitted about 28,000 observations. And actually, just this past water year, we've clocked in about 7,500-ish. And obviously, this depends on the storms coming in through the state. But like we heard today, maybe we can be more hopeful this weekend or in the spring to get more observations for this water year. But when looking at phase reports across the state overlaid with CWCB's planning basins, most of our reports come from the South Platte and along transportation corridors. And our hope is to reach more of these basins to get a better representation across our vast terrain and further support, like I mentioned before, these downstream effects of forecasting and operations. So with that, I'm going to hand it off to Keith to share more about our project.
Yeah, thanks, Nayoung. I'm Keith Jennings. I'm the Director of Research for the Water Resources Institute, University of Vermont, a longtime Colorado resident before moving here a few years ago. We do have snow currently, but I won't spend any time in this presentation making you all feel bad. So if we go to the next slide. Um, so Nayoung was talking about all these data we've collected over the past, gosh, almost 6 years now. And we've highlighted our efforts on mountain regions because that's where the differences between rain and snow tend to matter most. And essentially, the first thing we noticed with these participatory science data, which confirmed a lot of other prior research, is that the patterns of snowfall probability by air temperature do vary geographically. And so if you go to the next slide, we'll see what those curves look like. And each one of these represents a different mountain or near mountain ecoregion, and it shows the observed probability of precipitation being snow by air temperature. Now, a lot of places it's near about 1 to 2 degrees Celsius, but the one I want you to pay attention to that hits close to home is in the middle row on the far right, the Southern Rockies. The Southern Rockies actually has about one of the warmest rain snow air partitioning temperatures. So generally between 3 and 5 degrees Celsius. And then the particular data for mountain rain or snow is suggesting 4 degrees Celsius for air temperature for that split where that 50% probability of rain and snow occurs. So if we go to the next slide. When we started Mountain Rain or Snow, we had this idea that if we collected enough data and we created enough of these probability curves and we created enough optimized thresholds, we'd get to a satisfactory accuracy for rain snow partitioning across our pretty wide study domain. And this is important because we often don't have observations from mountain regions, participatory science aside. So we usually use computer models that use near surface meteorology, and those could be gridded data sets from NOAA. They could be weather temperature, other data sets from the National Weather Service. And so we'll typically use what we're calling benchmark methods, and these partition precipitation into rain or snow based on air temperature, wet bulb temperature, and other factors. And these could be thresholds, ranges, curves, and statistical models. And if we go to the next slide, we'll see what that performance looks like. And a couple things I want to highlight. We only looked at the best performing national level benchmarks, and their overall accuracy is ordered in this plot from top to bottom. So the methods at the top on the y-axis are the most performant, and the ones on the bottom are the least. And what we see is this really obvious, if you click forward one, see this really obvious pattern in the middle where accuracy goes down. And in some cases for the air temperature thresholds, we're looking at accuracies that are around 50%, meaning you'd be just as well off flipping a coin to determine whether it's raining or snowing. So no matter what method you're applying, you have this downgrade in performance at air temperatures above freezing, which is a problem because really those are the only air temperatures you care about for rain snow partitioning. Because if it's cold, you can pretty much guarantee it's going to be snow. And if it's warmer than that, you can pretty much guarantee it's going to be rain. And there's another thing I want to highlight with one click here is that the methods incorporating humidity typically outperform those that use air temperature alone. So if you're stuck with a single method or a measurement that you want to use, our recommendation across the board is to use wet bulb temperature. So 1 degree Celsius or half-degree Celsius threshold tend to perform best, both nationally and in the Southern Rockies as well. If we go to the next slide, we also see similar challenges and patterns in NASA's iMERGE product. This is a reanalysis data set that NASA publishes in near real time. And so there are groups, and you can use these to determine whether it's raining or snowing to help with your management and operations. This product, though it does perform well, the cooler and warmer temperatures has that same shortcoming with the air temperatures slightly above freezing. And also in many locations, it can't accurately represent warm snowfall, so snowfall that's occurring above 3 or 4 degrees Celsius, which is common in much of Colorado. And it also doesn't really capture sub-freezing rainfall very well either. So what we decided to do, if we go to the next slide, is look at some of the other reanalysis products from NASA that you might incorporate in some of your work. So not only iMERGE, but also MERA2 and NLDAS2, large-scale data sets where they ingest a lot of meteorological data and run it through computer models. And again, more shortcomings. So in the top and bottom plots, we would essentially want all of those cells to be colored the dark green in the top or the dark blue in the bottom, which would indicate that it's accurately getting rainfall and snowfall correct across all the temperature bands. And so rainfall below 1 degree Celsius or snowfall above 1 degree Celsius, that's where these methods tend to struggle most. And so they're not really accurate there. And most recently in mountain rain or snow, we decided, well, machine learning seems to be doing everything correctly now. Why don't we see if it can better represent precipitation phase partitioning? So if we can get better estimates of rain or snow and compare it to the benchmarks. And to do this, we used a random forest, XGBoost, and even an artificial neural network with different numbers of hidden layers. So we can have these really simple tree-based machine learning approaches and more complex neural networks, in some cases, a deep learning approach. But the challenge is that even with machine learning, as we see on the next slide here, is that they actually don't really improve on the predictive capability of the benchmark methods. So we're still in this point where using near surface meteorology, air temperature, wet bulb temperature, just reaches this limit that we can't seem to get across, even when we use methods like machine learning. In our particular study, the artificial neural network and XGBoost were more accurate, but the random forest, which can be quite performant sometimes, was slightly worse than the best benchmark method. But I should note that artificial neural network, even though it performed the best, it was only a 0.5% accuracy increase over the wet bulb temperature threshold. And I don't have time to discuss this today, but what we found is that there's a really large overlap in meteorological conditions for rain and snow at air temperatures above freezing. And the more overlap you have, so if you're getting more rain and more snow at a particular air temperature approaching that 50% mark, that you're going to have worse accuracy no matter which method you're using to try to partition rain and snow. And so in my last slide here, what I've done is create what I'm calling now the cycle of rain snow partitioning knowledge. Ideally, this would be something that was linear, where we start at one point and we get to a state of new knowledge in the future. And I'll walk us through real quickly before I hand over to Anne. And so we started with visual observations. This is where we wanted to remedy a shortcoming, which was that lack of rain and snow reports in mountain regions. So we started mountain rain or snow, started collecting these data. And then we thought, okay, well, maybe we can optimize the benchmark model methods. But what we found, all these benchmarks struggle at temperatures near freezing. Wet bulb temperature is best. And then we thought maybe reanalysis products, which incorporate a whole bunch of weather data, sometimes even upper atmospheric information. But these also struggle at air temperatures near freezing, and there are regional performance patterns and issues. And then we thought, okay, machine learning, that's really going to get us over the edge here. But these also struggle at air temperatures near freezing, and they only offer a slight improvement. So we've come all the way back around to mountain rain or snow, where we're pretty confident at this point that visual observations of rain and snow is the best way to observe precipitation type at air temperatures near freezing. And Anne will actually talk a little bit about now how we can use that in operations in her talk.
Great. Thanks so much. And thanks again for the invitation. So now you have all that background information, and I'm going to get into some of the operational applications. Next slide, please. So first, one of the studies that we did, this was in collaboration with the National Weather Service in Reno. We started looking at the snow level forecasts along the I-80 corridor, so passing from Sacramento over into Reno over the Sierra Nevada Mountain Pass, looking at Colfax, which is a lower elevation location, Donner Pass, at the summit over 80, Truckee, which is in a little bit of a rain shadow, and then Reno, which is, of course, leeward and in the rain shadow, looking at the snow level forecast for all of these. So on the scatter plot, you can see we have the elevation, and then this is a 48-hour forecast and 48 hours of observations. We had over 800, nearly 900 observations that came in just in this area during that single period. But you can see that around the 1900, 7 p.m. time zone that there was a forecasted drop from the deterministic snow level forecast, forecasted drop in snow levels. However, at around this 1,500 foot or 1,500 meter elevation, it continued to rain. And talking to the Weather Service in Reno, this is something that they said that they observe somewhat frequently, and it's a pattern that they recognize. So this really does speak to, as Keith was saying, that these mountain rain or snow observations, so all these people who are looking out their window and sending in those observations can give us that validation, but it also speaks to the value of probabilistic information versus deterministic forecasts. So the shaded areas of these forecasts is the 10th and 90th percentiles. And we can see that for these, it does actually capture that snow level staying a little bit higher. So the Weather Service is moving towards the National Blend of Models and HRRR as well, where they're going to be, where they are trying to give out more probabilistic forecast information. And this is some of the power in it, in looking at those high-end scenarios of what could occur instead of just the deterministic forecast. Next slide. So how can you access this data? There are two ways to access the data. The first is a public web map and data access. So this is at rainersnowmaps.com. It's updated daily with a 7-day latency, and that's because there's a lot of auxiliary information that's tagged along with this, and it goes through a QA/QC methodology. We'd be happy to share that. Some of it is embedded in the user guide on the website as well, but you can subset the observations to pick out the location, the time, or elevation, and download it as a CSV if you want to do some event analysis of what came through and how it looked in your region. And then this is ongoing in development, and eventually we'll have an overlay of some ancillary data sets. Next slide. So the other tool, and this is for forecasters, emergency management groups, so for operational use only, is a real-time situational awareness map. This has data that only exists for 6 hours. So it has the snow, rain, and mixed that only sits there for 6 hours. And as the time elapses, that dot gets smaller on the map until it disappears. This does not go through the quality control procedures. So that's why we want people to sign up. We want to make sure that they have that operational understanding and know the background of this data before using it, but you can get that real-time information and see the dots pop up immediately. This has been really valuable, at least in our region, as we do outreach, and we'd be happy to partner with any of you if you would like to help fill any of those observational gaps between stations, or hone in on regions where you know there's you need more information of the rain-snow transition. But we've been able to tell people, like, hey, if you ever feel like the forecast doesn't ever get right where you live, this is the opportunity for you to put the dot on the map and to communicate directly to the forecasters. The National Weather Service in Boulder does have access to this map and use it for their operations as well. So this really closes that connection for citizen science of collecting that data and putting it into the use of the people who impact them and their society, and then they can receive that benefit immediately. Next slide. So this is just a quote from Brian Brong, who's a Science and Operation Officer at the National Weather Service in Reno, who talks about how he uses this map in their operations. And here he says that this really fills the gap between the reports at the airports, the webcams, and snow level profiles. And these reports really help them assess how the forecast is aligning with observations. And then they can change their messaging and partner briefings, especially during rapid changes in snow level. Because being off by an hour or two can change the forecast and greatly impact, especially travel during peak commute hours, airport operations, and the staffing requirements for DOTs. So this is getting at that real-time situational awareness, having better understanding of what's happening where. And it's really carried by all these observers and people who are participating day to day. So if you go to the last slide. Oh no, one more slide. So one call to action is, if you would like to become an observer and help put the dots on the map, we would greatly appreciate that. Any opportunities with your agencies to collaborate and help grow the observer network in this region would also be hopefully mutually beneficial. We do a sign up by text. So if you would like, you can, with your phone, you can scan the QR code. You would select your region. And the reason why we do this text to sign up is because we have someone on staff who monitors the forecast across all of the keywords. And then we send targeted text messages, as Nayang mentioned before. We send these targeted text messages to alert them and tell them to keep their eyes on the sky with the short forecast information, and make sure that they're activated and ready to participate. Okay, final slide. I believe now. So with that, I would really like to thank you all for your time. Again, here are some QR codes to access the real-time map, to become an observer, and then for the data dashboard of that Q Seed data portal. I don't know if we have any time for questions, but if we do, we'd be happy to take them.
Fantastic. Thanks, guys. It looks like we do have one question in the chat. Justin says, love this mountain rain or snow citizen science push. He's curious if there are any future integration plans with other programs like CoCoRaHS, which is run by CSU, to increase observation density and potentially help model outputs.
Yeah, Na-Young or Keith, do you guys, either one of you want to take that? I know we have done stuff with CoCoRaHS.
Keith, you can start, and then I
Okay.
can add.
Yes, CoCoRaHS is one of our favorite, most trusted partners. So they have been instrumental in really helping us grow from a Sierra Nevada focused to a national focused project over the past few years. And they've really done that out of the goodness of their hearts. And we're looking to collaborate with them on some future projects. But yeah, can't really say enough things about CoCoRaHS and the data they have generated and the community they've created over the past 15, 20 years. I'm sure someone on here knows the full duration of their program. But yeah, it's been great.
Awesome. Well, thank you guys so much. And I signed up, so I'll be putting my observations in hopefully this weekend. Um, all right. I think those are all the presentations we have today. I know that in the chat there was a question about soil moisture. And it looks like Ali and Brian were able to answer those questions in the chat. Um, and yes, these PowerPoint presentations will be available by the end of tomorrow on the WCMC website, which I can put in the chat. Um, all right. Well, okay, we're at the end of our meeting, and I would love to hear before we hop off any water providers, water managers on the call if you want to provide any updates on how conditions are looking like in your neck of the woods.
I can kick us off.
Thanks,
Nathan
Nathan.
Elder, manager water supply for Denver Water. So we're pretty concerned with current conditions. In our area, the Colorado River snowpack is only 52% of normal. That's about 4 inches of SWE behind. In the South Platte, 41% of normal. 3 inches of SWE behind. Even if we get an inch of SWE from this upcoming storm, we're still going to be third or fourth worst snowpack we've seen for this time of year. Reservoir storage, we're slightly below average. Right now, we're 82% full. Normally, we'd be about 86% full. But with the level of where the snowpack's at and our reservoir projections for later this summer, we're really closely monitoring conditions. We're starting communications with customers, and we're ready to implement a drought response if these conditions don't improve.
Thanks for the update, Nathan.
Hi, this is Melissa Owens with Aurora Water. I'm a hydrogeologist, and we're also concerned about the snowpack. I'm not going to lie, I'm having a little anxiety after listening to the presentations today, but our storage is at 59%, and we have gauges in the South Platte that typically freeze in November, and they are still active. So that's really concerning. And we do have an internal drought action team, and we're meeting more frequently and discussing, what is going to be the next step. And, come spring, are we going to go into drought restrictions? And I guess it's just going to depend on how the rest of the winter goes. But that's my update for the group.
Thanks, Melissa.
Hi, I'm Beverly Richards with the Upper Gunnison. We have 62% sweet in the upper basin. However, that's still the third percentile, so we're pretty low for this year, for this time of year. Our precipitation is 84%, but that is kind of bumped up because we got some of that precipitation in October. Other than that, there is no snow at lower elevations at all. It is all melted out. So, and it has been warm here. Gunnison is typically in below zero conditions in January. We've had none. So we're hoping maybe this weekend we'll get some cold weather, so it'll help with soil moisture. Thanks.
Hoping for that for you, Beverly.
Howdy. This is John Orr, City of Thornton. Our storage right now is about 85%. It's we've had actually a really good year, keeping storage up nice and high. So going into the summer, we're looking good, except because of the snowpack. Our production year to date is down it says 4.42% from last year. And that's also a good indicator. So our customers are responding to what they're hearing on TV and every place else, maybe. Of course, this is winter consumption, so it's hard to say. We are meeting to discuss the snowpack and also the stream flow forecast. And we're trying to determine a course of action with this drought. The drought has worsened in our two main watersheds, the Upper South Platte and Clear Creek, over the last few weeks. And so we're not optimistic. Well, I'm not optimistic that things are going to improve. And right now, I'm wondering if Stanley Lake will fill, since that's an important part of Thornton's water supply. The South Platte, we don't usually have too much trouble until the Burlington ditch is called out, and that might happen earlier than normal. Good old normal, right? So that's Thornton.
Thanks, John. Anyone else? Drew said Westminster is a very similar place as Thornton, relatively high storage, but Loveland and Berthoud snow tells are tracking at all-time lows. So no good for Clear Creek flows. Thanks for the update, Drew. All right, last chance to provide any local updates. All right, hearing none. Thank you all for, oh, John, go ahead.
No, I was getting set up to say thanks. See you
Okay.
next month.
Thanks, John. Yeah, I'll see you all next month. The next Water Conditions Monitoring Committee will be on February 24th, same time, 9:30 to 11. So I'll see you all next time, and thank you all for your time.